Hi guys, in today's video we're going to look at dynamic equilibria, mole fractions, partial pressures, Kp, and finally an exam style question.
Let's begin by looking at dynamic equilibrium. When we know exactly what dynamic equilibrium are, we know that's a reaction where there's both a forwards and a backwards reaction, and it's indicated by these two half arrows here. And we know by equilibrium law that the rate constant Kc can be indicated by this equation here, where each reactant is raised to the number of moles that occurs in the reaction. So let's now have a look at the types of equilibrium. Well, there are two main types. There are either homogeneous or heterogeneous equilibria. Now, in homogeneous, both the reactants and the products are in the same state. In heterogeneous reactions, there are multiple states. We can have solids, liquids, and gases involved in our heterogeneous equilibria. Now, the molar concentrations of both solids and liquids don't change, and for that reason, solids and pure liquids are not included in our rate equation. Only gases are. And that's a very important point and something we need to remember. So now let's have a look at mole fractions. Well, mole fractions is the amount of a component in a reaction mixture. And here, this is our symbol for X, A, our mole fraction of our reactant A. And this is the number of moles of A divided by the total number of moles in our reacting mixture. This is an important equation. And again, there'll be questions that are 1 or 2 marks, asking you to work out the mole fraction and building up to bigger marks later on. So let's now have a look at partial pressures, which takes the idea of mole fraction a little bit further. The partial pressure is the pressure exerted by a gas if it were to occupy the reaction vessel individually. So if we had, say, for example, a mixture of hydrogen gas and oxygen gas in a reaction vessel, the partial pressure of our hydrogen would be the pressure exerted if the hydrogen was to occupy that vessel alone. And the way we work out the partial pressure is to take the mole fraction, which we just learnt how to calculate, and multiply that by the total pressure involved. Again, this is an important equation, one we need to know and be able to use, because 1 or 2 mark questions will ask you to work out the partial pressure or to define the partial pressure or to recognise this equation. So it's something we need to be able to use really well. So let's now have a look at Kp, a slightly new constant. Kp.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.